So what is an optimization problem? So these are usually in simple terms, more informally. They are problems which ask for either minimization of something or maximization of something. Okay, now? More. So that means what is that something they ask for minimization or maximization? That we call it as objective function. Objective function. For example, if it is a graph coloring problem, what is that it asks for? Is it minimization problem or maximization problem? Optimization problem which asks for minimization of that objective function, no, that we call it as minimization problems. Which asks for maximization of that objective function, we call them as maximization problems. Now in case of graph coloring problem, what is that we look for in case of graph coloring problem? What is that we minimize here? Total number of colors required to properly color the vertices of graph. That is number of colors used in proper coloring of the graph. That's what we are minimizing. What is minimum spanning tree problem? Is it minimization problem or not? Is it minimization problem? Yes. What is that we are minimizing here? Weight of spanning tree of given graph. So what is longest common subsequence problem? What is that we are doing here? We are maximizing something. Okay, no, subsequence which is present in both sequences where the length is maximum. Knapsack problem, what is that we maximize? What is that we maximize? Total profit of the selected items according to the given conditions. Now consider a problem, matrix chain multiplication problem. So the problem here is we are given a chain of matrices like this, A1, A2. That means it is chain of two matrices, A1, A2, A3. It is chain of three matrices, A1, A2, A3, A4. It is chain of four matrices like this. We are given a chain of matrices. Matrix means again each matrix should have some number of rows and some number of columns. So for example, A1 is given, A2 and A3. Three matrices are given. So first one is 10 by 20. Second one is 20 by 30. Third one is say 30 by 40. Now our goal is we need to find the product A1, A2, A3. A1, A2, A3. Is that correct? Okay. So if you are given only two matrices, A1, A2, first one is 10 by 20. Second one is 20 by 30. How many multiplications are required? How many element multiplications are required to find the product A1, A2? How many element multiplications are required? How many element multiplications are required to find this product? Last class we discussed, no?
10 into 20 into 30.
10 into 20 into 30. In this case, 10 into 20 into 30. This we call the scalar multiplication. So number of scalar multiplications is in this case is 10 into 20 into 30. For example, if we are given three matrices, how many different ways we can find the product? One way of finding the product is calculate A1, A2, that result to multiply with A3. Is it correct? Is there any other way of calculating the product?
First, we can multiply A2, A3, and then result can multiply with A1.
This is another way of multiplying. Is that okay? Now, if at all we are multiplying it this way, in order to find A1, A2, how many multiplications are required? How many multiplications are required?
6,000.
A1, A2. This we have already done here. It is 6,000. 6,000. So that means what is the order of resultant matrix? In order to calculate this 6,000 scalar multiplications, what is the order of this resultant matrix?
10 by 30.
10 by 30. What is the order of A3?
30 by 40.
3 by 40. Now, in order to find the product of these two, how many multiplications, scalar multiplications are required?
12,000.
10 into 30 into 40. That is 12,000. So total is that correct? Total number of scalar multiplications in this case is 18,000. Same thing. This is one way of doing. This is say other way of doing. In this case, how many scalar multiplications are required? That's what we calculate. If we want to calculate A2, A3, how many scalar multiplications are required? This is 20 by 30, 30 by 40. How many scalar multiplications are required?
24,000.
So this is the resultant matrix order is 20 by 40. And for each entry calculation, every row contains 30 entries. Similarly, corresponding column contains 30 entries. So for every row, 30 multiplications we need to perform. No? Do all of you remember this? No? Okay. So total, how many multiplications are required to calculate this? 20 into 30 into 40 scalar multiplications. Okay. So A1 we have, A1 is 10 by 20. This matrix it is 20 by 40. 20 by 40. Now in order to find this product, how many multiplications are required? Is that correct? Now what is total number of multiplications in this case?
32,000.
Yes, 24,000
plus 8,000.
8,000. So 24,000 plus 8,000, that is 32,000. That means what? For given dimensions or orders, okay, if both ways of multiplication, no, they may not be requiring same number of scalar multiplications. Both ways of finding the product of given chain of matrices may not be requiring same number of multiplications when n equal to 3. The same thing may be true with 4 also, 5 also, 6 also. Is that correct? Now what is our goal? We are in general, we are given a chain of n matrices, A1, A2, A3 and so on, an. So here, to know what is the order we are following to find the product, no, we are simply placing parentheses, no? Parentheses appropriately. So that parenthesization, which tells us what is the order we need to multiply matrices. Is that correct? Okay, that's why we are given a chain of n matrices A1, A2, An. Okay, now where matrix AI, which has say Pi minus 1 rows, Pi columns. That is dimension of that. Okay. Now we need to parenthesize this chain. That means we need to place parentheses such that it gives me what is the order in which we need to multiply that matrices inside that chain to get the product A1 to An. But what is our goal here? What is our goal? that multiplication should minimize the total number of scalar multiplications. That multiplication should minimize total number of scalar multiplications required to find the product. Is the problem definition clear? What is matrix chain multiplication problem? If we are given two matrices, 10 by one matrix A1 and A2, one matrix A1 with order 10 by 20, and the second matrix A2 with 20 by 30, in order to find the product A1 and A2, how many multiplications are required? 10 into 20 into 30. Is that correct? Is that correct? Is that correct or not? Is there any doubt in first this? Okay. Similarly, if we are given, say, three matrices A1, A2, A3, first matrix 10 by 20, second matrix 20 by 30, third matrix 30 by 40. So what is, if I use the terminology, this is P0, this is P1, this is P1, this is P2, this is P2, this is P3. Is that clear? Okay. Each chain of three matrices, there are different ways of finding the product, that chain product, okay, no, chain product. And each way, the number of scalar multiplications performed, it may be different. Hence, the goal is you give me that way where the total number of scalar multiplications is minimum. The total number of scalar multiplications is minimum. Is that okay? Is the definition of the problem, is it clear? Or in? Okay. Now, give me. Okay, what is brute force way of solving this problem? What is brute force way of solving this problem?
Find each and every combinations and check what is the number of multiplication.
What is that combination? What is that combination? Correct.
Like
Whatever you said is correct. What does combination mean here?
Means number of rows and number of columns adjacent matrices.
Your answer is correct. Combination here means each possible way of finding the product. A1 to AN product. For example, in this case, if we are given three matrices, we have two different ways of finding the product. Similarly, if we are given three matrices, how many different ways are there if we are given four matrices? A1, A2, A3, A4. Okay, first one is 10 by, it is understood, say something like this, 10 by 20, 20 by 30, 30 by 40, 40 by 50. You don't worry about this. Okay. Now, how many different ways we can find the product? A1, A2, A3, A4. How many different ways we can find this product? One way is, I'll place A1, after that I'll put parenthesis here. A2, A3, A4. Is that correct? Is it a valid parenthesization? Is it a valid parenthesization or not? Is it a valid parenthesization or not? Is it a valid parenthesization or not? No. It doesn't clearly tell us how to multiply A2, A3, A4, no? A2, A3, A4. So here again, we need to clearly mention how to multiply A2, A3, A4. So after calculating A1, A2, A3, A4, we may be calculating something like this, as discussed earlier. First A2 we may multiply with A3, A4. Then the final result we can multiply with A1. Is it correct? That is one way. What is the other way of doing? A2, A3 you calculate first. That result to multiply with A4. Whatever we get, that you multiply with A1. Now, is it a valid parenthesization or not? Is it
yes, it is valid.
Two parenthesizations we have got. So now, next option, what I do is, first one matrix, one group, next to three matrices, other group. First two matrices, I'll make it one group. After that, how many are there? By default, this is the only group. No, is it valid parameterization? Valid way of multiplication? Is it valid
Yes.
way of multiplication? Yes. Now, first three matrices, I'll make it one group. Next to matrix, another group. Now here again, how many ways it gives? Is it valid parameterization? No. It doesn't clearly say how to multiply A1, A2, A3, A1, A2, A3, no. So now can you tell me what is the valid here? Can you give me?
A1, A2 parenthesis over. Okay, that is also fine. Then A4.
Is this correct?
Yeah, correct, sir.
This we can multiply with A4. So now if we are given four matrices, four chain where n equal to 4, matrix chain, 4 matrices, how many different ways we can parameterize? How many different ways we can parameterize?
5 different.
5 different ways. Now each one we can call it as this is one combination. How many combinations we have here? How many possibilities we have? 5 possibilities. Like that. If we are given n matrices, how many possibilities are there? Brute force algorithm. Only one matrix, n equal to 1. How many ways we can parameterize? Simply if we want, we can put like this. Without parenthesis also, it doesn't affect. How many ways are there? Number of ways. Number of ways. 1. If n equal to 2, how many ways we can parenthesize?
Also 1.
Yeah, 1 if you want, because 1 also we are putting no parenthesis. This entire thing we can put like this. So this is again 1. N equal to 3. Okay, I am not drawing. You please tell me how many are possible? Number
2
of
ways.
2 ways. N equal to 4.
5 ways.
5 ways like this. Now, in general, given n, how many ways are possible? How many ways are possible? For example, if n equal to 5, what is that we do? If you are given A1, A2, A3, A4, A5, like this. First, what is that we do? First, A1, we take it separate, A2, A3, A4, A5. And we will see how many ways this is possible. Depending on that, again, here it is possible in
5 ways.
5 ways. Next, we'll take left side 2 matrices and right side 3 matrices. Again, how many ways are possible here? 2 ways.
2 ways.
Left side, I will take 3 matrices. Right side, 2 matrices. How many ways are possible?
Again 2 ways.
2 ways. Left side 4. Right side 1.
5 ways.
5 ways. Is it possible to do in other way? Left side 5 and right side 1. That is same as original problem. Right side 0. That is same as original problem. No? So this total how many? 5 plus. I think
14
it
ways.
calculated 14. Is that correct? No. I think it appears to be correct only. Now, in general, if we are given n matrices, we are given n matrices like this. N matrices, A1 to AN. How many ways we can parameterize? So one similar to this, what is that we can do? Left side and right side I call hereafter. So left side means wherever I am placing first parenthesis. Left side say one matrix. Right side, how many will be there? N minus 1.
N minus 1.
My meaning of left and right, is it clear? My notation of left, wherever I am placing first parenthesis, no? After 2 I am placing, after 3 I am placing here. Okay, this is A5, sorry. After 5 I am placing. Okay, now so here left side is 4, left to 4. Here left side it is 2, right side 3, like that. Or left to 2, the right n minus 2, left to 3, right n minus 3, left to 4, left to 5, n minus 5, and this one left to k, right side how many? Right side how many?
N minus
N minus k, and this one left side n minus 1, right side
1.
Okay. Now, what is our goal? N chain of n matrices, how many ways we can parameterize? Let P of n be the number of ways, number of different ways of parameterizing, different ways of parameterizing A1 to AN. That means chain of n matrices. Pn is number of different ways of parameterizing a chain of n matrices. Okay, no, this is for only, it's not even required. Okay, chain of n matrices. Chain of n matrices. Now, how many ways we can parameterize this left side then? If P of n is number of ways of parameterizing a chain of n matrices, how many ways one matrix can be parameterized?
1.
According to the notation,
T of 1.
how many ways right side it can be parameterized?
T of n minus 1.
This one left side,
T of 2.
right left side P of 3, right side P of n minus 3, and this one left side P of k, right side P of n minus k, and this one. Are there any possibilities other than this whatever listed here? Are there any possibilities other than whatever listed here? No. So how many cases we have? We can call it as case 1, case 2, case 3, like this, case n minus 1. This many cases we have. Is that correct? Yes. In first case, how many different parameterizations first case gives? How many different parameterizations first case gives? How many different parameterizations the first
T
case?
of n minus 1.
How many parameterizations first case gives? In terms of piece only, can you give answer, sir? See, we have left part and right part. Left can happen in P1 ways, right can happen in Pn minus 1 ways. Both left and right can happen in how many ways? P1
P of
into
n minus 1.
Pn minus 1.
Yes, yes.
Case 1, this can happen in total ways is P1 into Pn minus 1. How many ways? Second thing can happen, P2 into Pn minus 2. Third one, P3 into Pn minus 3. And this one, Pk into Pn minus k. Now we can generalize this. Let us take, now Pn, can we write it as Pn equals to P1 Pn minus 1. Okay, notation. P1 Pn minus 1 plus P2 Pn minus 2, P3 Pn minus 3. Here, what are the rules I used? Sum and product rules of combinatorics. Okay, Pn minus 1 P1. Is that correct? Is that correct?
Yes, sir.
So P of n, can we write it as sigma k equal to 1 to n minus 1 Pk Pn minus k? if n is greater than or equal to 2, and p of 1 we can take it as 1. Is that correct? Now, solution to this, it gives us what is p of n. In order to find p of n, we need to solve this recurrence relation. It is a recurrence relation, no? It's a recurrence relation. We need to solve this recurrence relation. If we solve Pn, we'll get it as it is similar to 1 by n plus 1 into 2n Cn. Is correct? What is P4? What is P4? 1 by 5 into 8 factorial by 8C4. It is 1 by 5 into 8 factorial by 4 factorial into 4 factorial. It is 8 into 7 into 6 by 4 into 3 into 2. 3 through get 6. Is P4 correct? What I calculated? 80%.
So that 8 into 5 is missing, no? 8 into 7 into 6 into 5.
No, this 5 and this 5 gets cancelled, no, sir. 5 into 4 factorial, 5 factorial. Here 14. 14 correct only. No, P of 4. P of 4, is it 14? No, P of 5 is 14, no?
5 is 14.
Okay. So we'll get a value approximately. Okay, now this reconciliation is similar to the highest order term in the solution to this reconciliation. Okay, let me erase this. That is, yeah, n plus 1 we can say. It is matching. N plus 1. Huh? This is called nth Catalan number. N plus 1th Catalan number is this answer. Is that correct? Pn plus 1 equals to, okay, let me, Pn plus 1. What is, okay, let us, this is, okay, this is whatever we calculated, that is P5, not P4. So that's why we can say that this is, this is order of growth is big omega, okay, big omega of what can you say about order of growth of this? Any clue? What can you say about order of growth of this? Four power n by n power 3 by 2. It is even more than 2 power n. It is more than 2 power n. It is, that means it is exponential. That means our brute force algorithm, what does it do? It brute force algorithm, what does it do? This reconciliation is similar to recurrence for nth Catalan number. Nth Catalan number. What is nth Catalan number? 1 by n plus 1 into 2n Cn. What is nth Catalan number? This is number of binary search trees possible with n nodes or n keys. It is close to that. Or big omega of 4 power n by n power 3 by 2. That means it is exponential. That means list out, that is enumerate all parenthesizations, Next, each parenthesization calculate number of scalar multiplications written one with minimum number of scalar multiplications. Is that correct? Brute force algorithm list out all possible parenthesizations. Okay, parenthesizations. Each parenthesization calculate how many scalar multiplications are required and return one with minimum number of scalar multiplications. What is the time this brute force algorithm takes? First step itself, it is this much. That means 4 power n power n 4 power n by n power 3 by 2. This is exponential. Each parenthesization, this we can do it in theta of n time. And after that, returning minimum, usually we can do it in theta of n time. Okay, by keeping graph, we can do it in constant time. Overall, this algorithm takes big omega of n power 4 power n by n power 3 by 2. Is that correct? It's an exponential time algorithm. Is that okay? Is there any doubt up to this? Listing out all possible parenthesizations, it takes exponential time.
How this complexity, big omega of 4 to the power n comes here? I don't understand that.
That reconciliation we need to solve, sir. That again, that itself takes time.
Okay. Did we solve earlier? Did we solve the same recurrence earlier?
This reconciliation. Exactly. This reconciliation I have not solved, but 1 by n plus 1 related to this, that is number of binary search trees with n nodes. That I have done using generating functions.
Okay, I'll refer it here now.
Using generating functions. Is that okay? Okay. For that, we need to know how to solve reconciliations, all those things that are different. Okay. So now, next question is it possible to solve this problem in less than exponential time? That means in better way. This is 4 power n, at least better than 4 power n, say 2 power n or something like that. Now, say for example, we are given a chain of matrices like this. This one A n. We are given a chain of matrices. Now, okay, let us take some small example. So this is optimal way for to calculate A1 to A6. A1 to A6, this is optimal parenthesization. Optimal parenthesization. Okay. Now, what can you say about optimal way of calculating the product A1, A2, A3? If we know that this is optimal parenthesization for this, what can you say about optimal way of finding the product A1, A2, A3? And similarly, what can you say about optimal way of finding product A4, A5, A6? Are you, is the question clear? See, we are given chain of 6 matrices, say A1 to A6, A1 to A6. So A1 to A6, that is optimal, whatever is shown, that is optimal way of parenthesizing, multiplying, okay, using minimum number of multiplications. Okay, now that is optimal way of finding the product A1 to A6. Now you tell me what is the optimal way of finding the product A1 to A3?
First A1, A2, then multiply with A3.
Why is it so, sir? So what you are saying is, first A1, A2 we need to multiply, that we need to multiply with A3. Similarly, what is the optimal way of finding the product A4, A5, A6? This is correct. This is also correct. Why? Why? Okay, let us calculate first. However you calculate, what is order of A1, A2, A3? What is order of A1, A2, A3? We use the same notations. What is AI order is? Pi minus 1 rows, Pi columns. Okay, Pi minus 1 rows, Pi columns. What is order? What is the order of resultant product A1, A2, A3?
P0, P4.
P0, P4 or
P3, P3.
P0, P3.
Yes, yes. P0.
This is P0, P3. What is the optimal way? However we multiply, what is the order of A5, A4, A5, A6? However we multiply, what is order of A4, A5, A6?
P3, P6.
What is order of A4? It is
P3,
P4
P4.
minus 1, P4. This is P6 minus 1, P6. So order will be finally this, no? So this is P3, P6. After knowing this result and this result, how many multiplications are required to calculate A1 to A6?
The scalar multiplications are P0 into P3 into P6.
So number of multiplications we can say that here this is again two matrix multiplication, no? Two matrix. This is one matrix. This is another second matrix. So number of multiplications is P0, P3, P6, P0, P3, P6. Is that correct? Is that correct? Okay, let us use some notations here. Let us say M1, 6 is minimum number of scalar multiplications required to compute or to calculate A1 to A6 matrix chain which contains matrices A1 to A6. Is that okay? Is that okay? Now tell me, this minimum number of multiplications for this, it is M1, 6. Now what is this value? What is this called? In order to compute A1, A2, A3 using minimum number of multiplications, what is that called? M1, 6 is the notation we are using to find the product A1 to A6. What is the minimum number of multiplications? For A1 to A3, what is the number of multiplications required according to the same notation, similar notation?
M13.
M1, 3 we can say. Here, what is the number of multiplications similar to that?
M46.
M46. So if we know that this is the best way to multiply, then what is M1, 6? We can write it as M1 comma 3 plus M3 plus 1 comma 6 plus P0,
P0,
P3, P6.
P6, yes.
Is that correct? Is that correct? Instead of that, for example, is there any other way? For example, left side we have say 4 matrices. Left side we have 4 matrices. That means this is left side 3, right side 3. For example, left side we have 4, right side 2. Then what is that? Is the optimal way. That is optimal way. Now what is the answer? What is the answer? Left side 4 means what are those matrices?
M14, M14.
This side A5, A6. What is order of this A1? This after multiplying, what is its order? P0, P4. This order will be P4, P6. Is that correct? Is that correct?
Yes, sir.
So now, what is M1 comma 6 can be written as M1 comma 4 plus M4 plus 1 comma 6 plus P0. After finding these two, how many are required? P0, P4, P6.
P4, P6, yeah.
P0, P4, P6. Is that okay? Is that correct? Now instead of that, if I know that left side there are 2, right side 4, what is the answer? Left side 2, right side 4. Is this correct? Is that correct? Because see, left side 2 means M1 comma 2, right side means remaining 4 matrices M3 to 6. P0 always the resultant will be with this matrix number of columns, rows. No, here it will be number of columns here, that is P6. This resultant matrix, it requires P0 rows and P6 columns. How many multiplications that it decides? It decides. If it is 2, here we will get to 2. Here, if it is 4, here we will get P4. If it is 3, here we will get P3. Is that correct? Now, for example, left side 5, right side 1. What is the answer? What is the answer? What is the answer? P0, P6. But here, what is the value we get?
P5.
P5. Is that correct? Now see, this P2, it is 2, this 2. This P4, this is this 4. P3, this is this. Is that correct? In general, now we generalize this. Say, now let us say we are given matrices AI plus 1, AI plus 2, something like this, up to AJ, where J is greater than or equal to I. Okay. In order to find this product, minimum number of multiplications required, we call it as Mi comma J. What is Mij? What is Mij? Minimum number of scalar multiplications required to find the product AI to AJ. Is that okay? AI to AJ. Is that correct? Is that correct? Now you tell me what is value, what is Mi comma J? What are the possibilities? That means total Mi comma J means total how many matrices are there? How many matrices are there? AI to AJ means how many matrices? What is chain length? What is chain length? That means number of matrices in the chain. How many matrices are there? Is that correct? J minus I plus 1. Is that correct? Number of matrices from AI to J, AJ. How many matrices are there? J minus I plus 1. Now tell me what is Mij? See, total J minus I plus 1. Left side it may be one matrix. Right side how many? Right side how many? Is that correct? J minus I plus 1 minus 1. If left side 2, right side? If left side 3, right side? If left side 4, right side? And so on. If left side K, right side? Okay, instead of K, let us use L. L, right side? If left side J minus I, right side 1. Is that correct? Is that correct? Is that correct? Now in this case, what is Mij value? What is Mij value? Left side only one matrix.
1 1.
1 1 means II
I
plus
Mi plus 1 comma J plus Pi minus 1 Pj. No, Pi. I minus 1 Pi.
Is that
Pj.
okay? Is that okay? Now, for example, if I have divided like this, AI plus 1 and so on up to AK, this is one side, AK plus 1, AK plus 2, and so on, AJ other side. In this case, what is answer?
MIK
M
IK plus MK plus 1 to AJ J plus Pi minus 1 PK PJ.
is that correct? Now Mij is Mik plus 1. But what are the values K can take? What are the values K can take? Whether K can take value of I? Whether K can take value of I? If K equal to I means there is only one matrix left side, no? K equal to I plus 1 means two matrices left side. K equal to I plus 2 means three matrices left side. I plus 3 means four matrices. It goes like this, no? So that means what is the final value K can take? What is the final value K can take? What is the final value K can take?
N minus
And
J
J
minus
minus 1. What that means what? AI to J minus 1 left side, AJ right side. Is that okay? Is that okay? Is where what are the values k can take? I2, j minus 1, any value. I2, j minus 1, any value. I2, j minus 1, any value. I2, is it clear or any doubt? Is this clear?
Yes, sir.
But do we really know what is the value of k? We don't know. That means how to calculate Mij then? Mij. So first Mi comma I, Mi plus 1 comma j plus Pi minus 1 Pi Pj we calculate. Next, in order to calculate this, we need to calculate this. Next, Mi comma I plus 1 M I plus 2 comma j plus Pi minus 1 Pi plus 1 Pj we need to calculate. Next, Mi comma I plus 2 plus M I plus 3 comma j plus Pi minus 1 Pi plus 1 Pj we need to calculate. And so on. Finally, I comma j minus 1 M j comma j plus Pi minus 1 Pj minus 1 Pj. Is that now actually Mij is either first value or second value or third value or and so on, j minus ith value. J minus ith value. So what is Mij actually? It is minimum of all these values. Can you say? It is minimum of all these values. Is it minimum of all these values? Is there any doubt here? Is there any doubt?
Sir, just in the third line, I want to make sure. Mi I plus 2.
Okay. This is I plus 2.
Yeah.
Okay. Thank you.
It's fine.
Is that okay? So now what is this entire thing is if j is greater than or equal to I, j is greater than or equal to I. If j equal to I, what is Mij if j equal to I equal to j? That means only one matrix is given.
Yes.
A1 is given or A2 is given, only like this we are given. Do we need any multiplications? 0. That's why we can simply say Mi comma I is equal to 0. So now what is the reconciliation we have got? So now can we say something like this? M of I comma j equals to minimum of k, I less than or equal to k less than or equal to j minus 1, M I comma k plus M k plus 1 comma j plus Pi minus 1 Pk Pj. Is this clear? Are any doubt in this? Whatever we have done, so that means AI2 AK one group, AK plus 1 to AJ another group. Here number of multiplications required is MIK according to our notation. Here number of multiplications according to our notation is k plus 1 comma j. after multiplying this one will have order pi minus 1 pk, and this one will have order pk pj. So resultant matrix, again to multiply both this, we require pi minus 1 pk pj number of multiplications. That's what I have written. But we don't know what is the value k takes. That means k can take any value from I to j minus 1. Is it clear or any doubt? Is there any doubt in this? What is actual answer to given problem? M1 comma n is actual answer. M1 comma n1 is actual answer. M1 comma n is actual answer.
Yes.
Okay. So now, based on this, is it possible to write a recursive algorithm? Based on this, is it possible to write a recursive algorithm? We can simply write a recursive algorithm. This is simply recursive algorithm based on this. But what is the time this recursive algorithm takes? Okay, otherwise I stop here. Okay, next class will continue. Can you quickly tell me what is the time it takes?
Is it said that we computed earlier 4 to the power n? Is that one?
Yes. What is the time this algorithm takes? Can we say that still it is it exponential or not? Easily we can show that it is 2 power n. Can we say that it is 2 power n?
Yes. Okay.
Why 2 power n? Why, if there are n matrices, one side one matrix, one side n minus 1, one side 2, one side n minus 2, and this one side n minus 1, n minus 2, one side 2, one side n minus 1, other side 1. That means if Tn is the total time, this becomes time will be T of 1, this will be T of n minus 1. This will be T of 2, this will be T of n minus 2. This will be T of n minus 2, this will be T of 2. Okay, so T of n becomes easily, at least we can easily say that it is greater than or equal to sigma, okay, 1 to n minus 1, k equal to 1 to n minus 1, tk plus T of n minus 1 minus n minus k. Is that correct? That means T of n easily we can show that greater than or equal to 2 times T of n minus 1 plus anyhow some constant, other work will be there, some constant. This is similar to our tower of Hanoi problem. Easily we can show that T of n is big omega of 2 power n. That means this is also exponential. This is also exponential. Then we get doubt. Why is it taking exponential amount of time? Why is it taking exponential amount of time? Okay, exponential amount of time. Okay, that we will discuss in next class. If you have